Yep, I think we probably should, Susie. So, Stephen, it's up to you if you want to show your face. So far, it's only been the presenter showing their face as sort of punishment for having to present.
Cindy's on board.
Yeah, and he just jumped right out of there. I didn't even have to.
Yeah. Do you want me to show my face now, or just?
Yeah, I am going to pop up our there, and let me just. Okay, so now I can't see myself, but Cindy, did you join in?
I'm here.
I'm just. Let me move this down.
Not on video. Yep, there she is.
Okay.
Hi, Cindy.
Hey, Cindy. Okay.
Now you got a high desert shirt and everything. Look at you.
And my gym behind me.
That's
perfect.
perfect.
All my bikes and treadmills and everything.
So I'm looking, and we got quite a few attendees who have come back and joined in. Usually this is a tough session slot after lunch, but everybody is at different time zones, so I think it's going to work out just perfect. This session is cluster analysis and regrouping sites based on analytical analysis. And I really asked Cindy to join and be a joint presenter on this because she has that heavy-duty math background. She's our statistician, and she'll be able to field quite a few of the questions that some of you may have on this. So just to start us off, everybody can see my screen and everybody can hear me, I'm assuming. If you can't, I can plug in my headset if need be, but otherwise, if everybody can hear me, I'm just gonna work off of it like this. Just a reminder, if you can't hear anything, put something in the chat. I am not monitoring it. Laura will be monitoring it, and she will tell Cindy and I if there's a question that you have. And also, the other reminder is that this session is being recorded. So I'm going to see if I can get this to work. Okay, so the topics that we're going to cover today, the goal of this session is to provide a basic level understanding of cluster analysis and its value in the traffic monitoring world. We're going to touch on two methods, traditional and cluster analysis on when you assign factor groups to a new site. And we've included 4 slides on examples of cluster analysis, pattern recognition, and image analysis to reinforce cluster analysis concepts. And as a wrap up, a few of the challenges that we face in the traffic monitoring world, and then how cluster analysis can help transportation agencies better understand their traffic data. So what is cluster analysis? And cluster analysis is a set of statistical techniques used for processing data. It works by organizing the items or data into groups or clusters based on similarities and differences. So let's think about and take a step back, how we got to where we are. And I titled this slide, Hand Me Down. And so this one, I want you to think back when you first joined transportation, and specifically traffic data program. And when you take a peek at some of these words like factors, let alone daily, seasonal, and axle, when I heard these words and terms, I thought I was learning like a whole new language. Bidding schemes is still like a mystery to me. So when you were in your position, think about how probably all of these items were defined and in place already. You didn't have to put them in place. And so any change to any one of these variables can really cascade and float down and affect downstream the AADP value. And it takes years and years of knowledge and experience to be able to understand that impact. So the more traditional method or approach that transportation agencies use when they assign a factor group to a new site is They take into account their familiarity or knowledge of the area, functional classification of the roadway, or the location, where that site is going to be located. And when I first started with DOT and in the traffic world, I was curious about how sites were assigned to factor groups. And so I called and outreached a couple of different DOTs, and I found out that yes, this indeed is the way the majority of the folks assign sites to factor groups. Some of you also use cluster analysis, and not everybody has, but it's a statistical analysis method that will look at your traffic data and partition and group it off into data similarities. And HDT runs a mathematical test to determine the cluster size for the study. And then you can, for site characteristic criteria, identify those when assigning short-term sites to a factor group. And for cluster analysis, then you're going to see either your existing sites or reassociated sites into factor groups. Some of the requirements of cluster analysis really looks at scalability, and clustering analysis needs to be able to deal with really large data sets. And when you think about your traffic data and multiple years of data, you're talking millions and millions of rows of data. And then when you look at WIM, and then when we started looking at IVR or PVR data, that really bolstered the amount of data that we have in our traffic database. Another requirement for cluster analysis is the need for no missing data. And clustering algorithms can be sensitive to noise. And what that means is if you have any bad or missing data, the algorithm is sensitive to that. And so it's possible to use and fill in where data doesn't exist. We use a rolling average. Sites that have more than one missing value may be eliminated from the study. In addition to, really, we can handle some exceptions in the clustering analysis. If there is a pattern that is a consistent pattern throughout, there is a possibility that that site still can be used in the study. So this one, I want to say, well, if many of you are like me and you're not a math guru, the output from a cluster analysis really has to be usable and understandable. And so when you look at that, pattern recognition is used in statistical data analysis, and it'll filter out the similarities and differences of your traffic data. Image analysis uses graphs to visually interpret big data patterns. And so when you look at these two types of techniques, they're really used together so that the study will show you how you can filter out or separate out sites that either fall in or fall out of that factor group. So I'm going to be turning this over to Cindy, and I really want to thank Nevada for sharing some of these slides. We thought some of the ones that I've just gone over will be reinforced when Cindy starts sharing and talking about some of the graphs that you're about to see. And Cindy is HCP's statistician, and she
Our first technical snafu, because it looks like she got dropped offline. So I'm guessing she'll be joining up again, but she's actually not in the meeting at the moment.
I think, Cindy, are you connected to the audio still? Because I show her, no, she's not
It says
there.
offline.
Yeah, she dropped out of the list of attendees, yeah.
Okay, well then for that, we'll just wait a second, but I do want to thank Nevada while we're waiting for Cindy to pop back online. And there's a few of their slides from their study that was done, I think, Chris, in 2016. And it's just a peek at how, looking at all your data over the course of multiple years, that you can see the relationship and, again, the things that fall in and out. So I'm going to wait 1 second.
I might be able to talk to them, Susie, if she doesn't get back shortly. I know we don't have a huge amount of time for this.
Okay.
Um,
I'm going to just go to the next slide and put it on there as we wait to see if she can pop back in.
okay.
And I thought that might be me who'd lose connection because 1 week I was having a lot of problems. So I'm glad that's not happening.
Hey, Joe.
Yes.
Yeah, this is Stephen, for those who don't know my voice. How do states associate their portable counts with the cluster grouping that has been provided by Jackalope?
Yeah, I mean, that's the $50,000 question, right? I mean, well, I don't know if you're getting into that in this presentation, Susie, I can't remember. But that's always the difficulty. The cluster analysis that we're going over here is not the hard part. It's then going back and trying to find, doing what we call a functional analysis, which is going through and kind of tweaking it such that you can create clusters around information that short-term sites have access to, like functional class, for example, although that's not usually a great way to do it, or land use or something like that. Because, yeah, I mean, you're right, Stephen. If we do a cluster analysis, you're not going to find that you have 7 distinct clusters representing each of the 7 functional classes. That never happens. It's always it's a lot dirtier than that. And so step 2 is to back away from that and try to find a sweet spot where you can get relatively good clusters, but using information that you have available in your database.
I think one of the things for myself and when I was at Wisconsin was thinking about that relationship specifically in terms of how do you use a cluster analysis to assign a factor group to a short-term or a portable count. And in some ways, that's why I feel the 2 methods aren't mutually exclusive. Using them alone, the traditional method gives you that ability to be able to assign it based again on that traditional approach, knowledge of the area, the location, in addition to the functional classification of that roadway. But when you look at the cluster analysis results, it gives you another perspective of looking at the data across the board over multiple years to be able to get a different feel for what you're seeing. And I think the 2 methods together may be something that well together.
Well, I think the cluster analysis informs the functional analysis. So you go and you do a cluster analysis and you say, okay, well, it looks like 5 clusters is ideal. And then you can go look at those 5 clusters and say, okay, this first cluster has these 7 sites. What the heck do these 7 sites have in common? And so that you can actually use the cluster analysis to then inform what you do later on with, okay, how do we assign short-term counts to these clusters? So I agree completely, Susie. It's not mutually exclusive. I think one informs the next.
Yes. Joe, I see Cindy's still not online. Maybe we should continue.
Yeah, I'll give it a shot. And I think this slide is talking about that. It's talking about trying to partition traffic data based on what we might think the data similarities might be. So here we've got various groups broken out by a combination of functional class and county. So we've got, functional class 1, interstate, I guess rural, interstate. Oh, these are the old functional class numbers I see. So O1, which is rural, interstate, gets split into 2 groups. And then the other rural functional classes also get split into 2 groups, and so on. I think that, I don't know if this is a result or if this was input to Cindy's process, but.
I think this was the result. I think when I was talking to Cindy, this was HTT on that slide where I said they use some mathematical test to determine the number of clusters in addition taking into account location and knowing the area. Both those variables were used to input and treat the number of clusters.
Yes, because this is an ideal endpoint because we know what short-term counts functional classes are, and we know what counties they're in. So this is, to address Stephen's answer, if the cluster analysis comes up with this sort of matrix, that's the ideal. That is exactly what we want. So this is an iterative process. It probably started off in the cluster analysis came up with 5 perfectly wonderful groups from which we could derive absolutely no information on how to apply short-term counts to them. And then we probably backed away from that and came away with this as being kind of the best fit between a perfect clustering solution and data that's available. Hey, Cindy.
I'm back. Sorry about that. That was weird. I got the blue screen of death and a weird noise coming from my computer right at the most unopportune time.
I think the weird noise is me talking. No, I'm just kidding.
Oh,
I was babbling on though. I was probably totally destroying your presentation. So.
well, I'm back if you want me to take over.
Right before this, I was introducing you, saying, hey, she's our statistician. She works on large-scale projects. She does the heavy duty, she's got heavy duty math skills, does the heavy lifting on those. And here's Cindy, and Catherine goes, Susie, I think she went offline. And I was like, oh, dang. Glad you're back.
And then you get to throw Joe into the mix, right?
That's right.
Okay, well, I'm back, and this is my screen. So I don't know where Joe was in this, but when we do a cluster analysis, the first step we do is we determine the cluster size. And previously it was always kind of guesswork and everything like that, but now there's a test where you could run and actually mathematically give you the optimal cluster size. Then we do the cluster analysis, we graph the results, and then the last step after that is we've got a bunch of groups and we got to make sense out of these groups. So when I did Nevada's cluster analysis on the daily and seasonal, and I did it separate. So I did a cluster analysis on the daily and the cluster analysis on the seasonal. And both the groupings were almost, there was 1 or 2 sites that were a little bit different, but for the most part, they were all in the group together. So Susie, go back just that.
Yep, I'm going to, I pressed the
Yeah,
button.
I'll hit that in a second, but go back to the previous slide real quick.
Actually, I'm going to change you to the presenter so that you.
I don't have the PowerPoint up because I was rushing to get back up.
Let
So
me
just,
okay, here we go.
thanks. So on these groups, we came up with 8 groups, and then we had to figure out, well, what's so special in each group, what characteristics. And Nevada was really, really easy. Some states are very hard in determining the characteristics, the common characteristics between the group, but Nevada really worked out where you divided them geographically in areas of northern and southern, and we only had 2 areas that broke out, so northern and southern, and then we had groups of like the interstate, the rural interstate, and then we had most of the other functional classes with the similar traffic factors. So that's how it ended up grouping. So we have these sites where it says the counties and the sites. We have these sites in each groups. Then we have to go back and figure out what's common characteristics of the sites. And that is the biggest weakness of cluster analysis right there. So the next slide.
Okay.
I had told you previous cluster analysis, you just guessed at the minimum cluster size that you wanted. So you kind of played around with numbers, but now they have a test. It's called Hartigan's rule. And what this is they do a ratio of your within group error for cluster size of 8 versus say a cluster size of 9. And then they do this ratio. And once that ratio gets below 10, that's your number of clusters that you want to use. And so it's arbitrary. You could do like 5 clusters or 6 clusters, but on this graph right here, what this says is we want to use 4 clusters. We can use more, but we don't want to use less. All right. So this is a great test, because then it tells you, kind of gives you a starting point, and you cannot do analysis with cluster analysis without putting in the number of cluster size you want first. So that's a big trick. Here's an example of the results of the Nevada cluster analysis I did on seasonal class. So seasonal class, you've got different groups. So you might have different traffic factors for your cars as opposed to your vehicle class 5s and then your vehicle class 9s. You'll probably have different traffic patterns. And so with that, you can also have different groups. So on this analysis, what we looked at is the traffic patterns of the different, the 5 bins that we had, or the 4 bins that we had. And here is an example of just one cluster and how it groups the traffic patterns together. If you notice on that site, the gray site, the 101 site, we got a big dip in bin 4 around March. That might, you know, something happened there, or else, you know, that's true traffic data. But when you average across that trend line, that kind of goes away. And so you have an average across your factors. So all the back and forth, that error goes away. And so there's an example with this cluster analysis. It does pretty good. You don't get a lot of, if you've got a lot of like drops, big variability, the average is going to be pretty much straight line if you've got, you know, up and down and up and down. But for the most part, that shows how good the cluster analysis can group sites with similar traffic patterns together. So that's one example. And then on the next slide, here is a slide of graphing what the average factors of the groups, traffic cluster groups, look like. And when it comes down to it, there's a certain seasons that make a big impact in grouping those clusters together. So for example, you see that huge peak around winter months. Well, that's, you know, so the difference between these groups are mostly what happens in the winter months for Nevada. So that's what this slide shows. So when I do a cluster analysis, once I get the results, I graph everything and make sure everything looks right and makes sense. You know, because it's kind of statistics. If it doesn't make sense, there's no use to you. So I have done some cluster analysis that I've got in groups, and I don't have enough site knowledge from that state to say what characteristics each group has. They're grouped together in a traffic pattern, but I don't know why. So, anything else? All quiet. Yeah. As soon as you start talking statistics, it gets really quiet, right?
Well, this is your area of expertise, and I really thank you for going over these slides, because I can look at them and understand them and can make some generalization about it, but I don't understand the engine behind it. And so I think what you've shared has been really useful for everybody. And so we're trying to, with this session, pair together some of the business side with the technical math stuff that is going on and to bridge it together. And so the next slide that I have is talking about one of my favorite things, variability of traffic data. And so prior to really becoming more familiar with traffic data, I don't think I ever used variability too much, but yet since then I've used it a ton. So what makes traffic data variable? And let me just try to grab that back. there. And traffic data and patterns change over time. We know that new businesses emerge that change the AEDT and volumes on roads. We know that roadway projects also are a big variable or factor in those patterns. In addition to, we have federal requirements. And I think the TMG, I remember 2013, I couldn't remember what was the TMG before 2013, but I recall 2013, 16, 20, and just looking in 7 years, the differences of how the traffic programs have changed, in addition to how the traffic requirements, as we look at it, as we look at MAP 21, the FAST Act, freight analysis, all those things that pull on traffic data. And so it makes sense, biped, how that is becoming bigger. So there are a lot of federal requirements that are coming down or guidelines that come in. And then we look at the HPMS, and transportation agencies are very responsive to the reassessment changes since HPMS data is used in many of the apportionment formulas. And what that basically means is your data goes in to federal highways in through and submitted through HPMS. And when we get that and they look at that data, a part of what your budget, your money that comes through SPR, et cetera, that the state gets is based on what is submitted. So transportation agencies definitely listen to what those requirements are. But that
Stephen
also
posed a question for Cindy. So at a good break point, we can read Stephen's question for Cindy.
Okay. The other thing is talking about pairing HPMS and Office of Safety, and then specifically Meyer 2.0. Back in the 2010 HPMS reassessment, I think that's where I first met Margaret. Idaho, Wisconsin, at that time I was with Wisconsin, and Montana, I think Chris Dorrington, the three of us were the final reviewers of the 2010 reassessment final report. And Margaret, I didn't memorize this, so I had to go back to the report to look at it. But in section 4.2.11, that was labeled safety in the 2010 report. And in that, it talked about adding motorcycle data. And again, we talked about this earlier. The challenges that the DOTs faced or transportation agencies faced, submitting HPMS motorcycle data. The first year we did that was in 2008. It required everybody to re-look at their bins, modify those bins again, and that created a lot of change in our data. In addition to that, there was a paragraph or a little mention about coordination of HPMS with other safety databases. So when Margaret brings up, hey, you know, I'm sitting on the safety side too, the importance of local paved AADT, we want it to be, or she wants that estimate to be good. Well, they mentioned specifically Meyer at that time, and they're talking about looking at how we're, as we mature these databases and the collection and submittal, we do want quality data. Lastly, variability of traffic data is hardware and software technologies. And in that, we had to tune our hardware, the equipment, as we were looking at adding in length data, the Wavetronics. I know we've gone from the 101 and the 125, 126s, different hardware that is used to collect more data, more lanes of data to deal with some of the occlusion that people get when collecting and light sources that can affect that. And then the software technologies themselves. So when we look at variability of traffic data, there are a lot of silos that go and mix together that create that variability, that create large and big challenges for us. I'm going to take a pause before I hit that last slide, Catherine, so you can ask Stephen's question.
Okay, he wrote that Cindy mentioned how winter and other seasons can affect the clustering. And he said, do you find it varying by state because of their different seasonal influences?
Yes, it's completely different, like in Nevada, that I ran in Nevada, than Missouri, when I looked at Missouri's data. So it really, like Nevada has a big magnitude of differences between seasons. So that really pushed the clusters in that way, whereas you might not have as much seasonality, and then it's more traffic geographical. That, I mean, it's state by state, area by area. I really see differences. So one rule that we do for one state is completely different for a different state.
Okay, he said thanks.
Okay, and then on the wrap up, just some additional things to ponder. And as we think about the value of cluster analysis, and again, cluster analysis is a great statistical data analytic tool to use in conjunction with your traditional methods. They're not mutually exclusive. You know, as humans, we can't understand and read traffic data and its patterns. And that's what the statistical data analysis does for us. It gives us a peek under the covers at those similarities and differences. Analysis done, I think you'll find that there's a lot of value to it. It uses and removes bias, and it provides you, the traffic coordinators, in addition to you being able to speak to your managers with a level of confidence about the quality of your data. And that's our last one, and opening it up for any questions and that any of you may have.
I had a comment. This is Catherine. I remember when the Nevada analysis was done, and Cindy, you touched on it, but we didn't go into much detail, in that it all broke out into the groups, but because you don't live in Nevada, you don't know what that necessarily means. It took a little bit of work with you plus them figuring out how to really dissect that and figure out what the details were. So you can get the statistics and it can give good information, but then there's some human knowledge that goes into it that we need to probably draw from local people familiar with their sites, right?
Oh, absolutely. I mean, we had to work with Nevada hand in hand, because I don't have the site knowledge, and you can come up with a lot of groups, and until you know what characteristics fall for each of those groups, there's no application to them. So that's the hardest part with this cluster analysis, is once you've got the groups, is to come up with the characteristics of those. There is some analysis that I can do, and I've looked at it, but I haven't gotten really good results of, so that we could mathematically do the whole thing using, it's called principal components analysis. And I get results, but you can't apply them to the short-term sites for their assignment there. So I have to go back to the traffic engineers and say, hey, what's common with all these sites? Why is this site, weird when everything else around it is fine? And usually it's like recreational site that it has a functional class, but it's actually a recreational site, and it's by the lake, or there's a ski hill up there, so that's why the traffic is a certain pattern. You can't throw out your common sense whenever you deal with statistics. You always have to look and make sense out of it.
And then once you all determined these characteristics, you were able to write scripts that could then automatically assign the sites to the groups based on these characteristics. And so therefore, in one fell swoop, basically, then all of the sites became associated with correct seasonal class and daily class factor groups.
Well, that's a good point. So, and we didn't really touch on it in the presentation, but with your assignments for seasonal class, you'll have different bins can be in different factor groups. So your bin 1, which is your vehicle classes 1 through 3, could be in one traffic pattern group, where your other bins might be in a completely different traffic pattern group. And so what we did on that aspect is we looked at them separately, and then we looked at them all in one, where we grouped them all based on bin 1 traffic pattern, bin 2 traffic pattern, and bin 3 traffic pattern, and 4. And it so happened that we got to keep the traffic patterns together. So if bin 1 is in traffic group 1, all bin 2 and 3 and 4 are also in bin 1. And that's how we set it up, partly because it's easier in managing traffic groups that way, but also that's how the patterns worked out too.
All right, we have another question from Christy, and her question is, will the factor group update scripts also create site time breaks? So Cindy, when you update the sites, are you capable of, I know this answer, but I'm gonna let you answer it. Are you capable of making site splits?
So that the site belongs to one factor group in one part of the year, and then a separate factor group for another part of the year?
Well, so historically a site belonged to one group, and then we did the analysis, and now it belongs to a new group from now into the future.
Hey, Christy, you want to chime in?
The way Catherine explained it is correct. Specifically, we are redoing all of our axle correction factor groups. So from like whenever we get them done, let's say 1/1/2021 going forward, they would use those groups. That's when those groups would exist. So if I needed to, mass update like 5,000 sites, I would like them to have a time break where they switched from their old factor group to their new factor group.
Yeah.
Didn't we do something similar to that, Cindy, in some other updates we just recently did for Wisconsin?
Yeah, I was
for
about
functional
to
classes.
mention that in Wisconsin. Yeah.
Yeah. Right, Cindy?
Right. Yeah, absolutely.
Yes.
I very much like that answer.
Hey, this
It's a
is
lot of
Rob.
work. It's not an easy task whatsoever, but yes. Okay, go ahead. Hi, Rob.
Hey, is there a kind of a common time frame you're seeing, Cindy, start to finish on this? I understand there's a lot of iterations and it'll depend on how soon the DOTs can get to it, but is it a couple weeks? Is it a month? I mean, generally speaking, how long does the process take once you begin?
I would say a month. It usually takes a month. The hardest part is step 4, the finding the common. I go in, and once I find the groups, that's not that hard, as long as we've gone through some quality control of the data and looking at the data itself. The longest step would be once I done the cluster of groups, finding some of the site characteristics where we can group them together and figure that out. And that has to be done with the state DOT, so hand in hand.
Want to assign someone with the time to also work with Cindy, not just using, you'd want internal time allotted also to be able to work with her.
Yeah, that's that, and then going through and then doing the new assignments takes a while.
Thank you.
Okay, if there are no other questions, and if you do have questions, you can always forward them to Laura, and I'm sure she will gather them, and we can get Cindy to answer them, because it won't be me.
And it won't be
okay.
me.
Yeah. I just want to see, can everybody see my screen?
Yes.
Yes.
Okay.
Does everybody recognize it? And Joe, you can't say it because we did this with you before. Anybody recognize what that is?
Should Stephen?
I do.
I know you do. You can't answer either, Drew. Does anybody recognize this?
Steven
looks like
says it's
state
a
of
clock.
Looks like Captain America's shield, but
If you've been at
Nice.
TFC, it's one of the structures up there that hangs going between the Marriott and the main convention center. So the TRB has these huge, really awesome looking different sculptures. One is like made of bar stools. One is made of tennis rackets. But I thought this one was really cool because it had all the states on it. And so-
Stephen also posted a question. Sorry, back to the analysis.
Good.
After that, I'm just interrupting. Has the proximity to an exit lane or a through turn lane affected clustering? So I guess at the lane level,
We don't cluster on the lane level. We're not clustering on that. So
Sorry, Cindy. It's hard to articulate it in one simple sentence. The question is really when you have a site and it doesn't fit, or it does fit and it maybe looks a little weird in certain aspects, and you look at it and then you talk to locals and the locals say, "Oh, well, that's a 3-lane road." Or that's a 4-lane road, but one of the road lanes is an exit lane, and so it has a weird traffic pattern, and it takes 25% of the traffic and somehow does something ugly to it that doesn't seem to match everything else. Does that affect the clustering sometimes when you talk to locals and you kind of get that information about the site?
yeah.
Okay.
What I would do, I would exclude that from that site from the cluster analysis, because what we're trying to do is find typical traffic patterns. So using you have to have at least a year's worth of data so that you have all your factors in there. I would actually exclude out sites that have really weird, untypical traffic patterns. And that just goes in your bin of here's a separate site that hopefully won't have a lot more traffic sites that have that same weird traffic pattern. But
Yeah.
for cluster analysis, you throw those outliers out.
Okay. States are installing these sites, and we're getting asked about it in regard to the 2021 TMG with handling turn lanes and things like that. Because they want to have permanent sites where they're collecting the data, and they want to properly code them for submitting the data to federal highways. So.
another question from Christy. How often should factor groupings be evaluated? What's that recommendation? Probably once is a good idea, and then.
I don't know. I mean, Stephen, is there anything in the TMG? I mean, it's always going to be a resource consideration to balance. I mean, sure, just do it every year for every one of your factor types. That's the proper time. But no one can do that because you'll be spending all year doing this. So, Stephen, is the TMG? Oh, is that what it says? Every 3 to 5 years?
3 to 5 years. Susie, you're muted. We can't hear you.
Am I muted?
No,
You're not.
Susie.
Oh,
I shouldn't be. So am I
Now
still
you are.
muted?
Nope,
No,
you're
we
good.
can hear you now.
Alrighty. Yep. That's what I was about to say because Stephen, I saw that in the TMG also 3 to 5 years.
so one thing we didn't bring up, Susie, was the number of sites within a factor group. Did you talk about that while I was gone?
No.
Okay.
No.
So some of our states have a ton of factor groups where they only have 1 or 2 sites per group. And so I would say when you do a cluster analysis, it really kind of helps to collapse those groups, and so that you have more sites per group.
A lot of times we see that, Cindy, where they'll have an individual site be its own factor group, but those sites will also belong to a group that is truly a group of multiple sites. And then they'll do that when exactly this weird thing will happen where they don't have a short-term site that really matches the group, but it might really match that site, or it might be just so close in proximity that using that ATR site makes sense to use its factors. I don't know that they use the individual, and there are a few states in attendance here that have this condition of, one site is a group, but I don't think they're submitting the data to anyone based on a one site group.
Okay.
I don't know.
Mark has
Yeah,
her
the TMG, like Steven says, the TMG says a minimum of 6 per group, but there are 2 different paradigms, like Catherine was just talking about. There's the reference site paradigm, where you associate your short-term counts to a particular continuous count. I think that's different than just the factor group paradigm, which is where you're creating these aggregates that all have common variability. And for that, like Steven says, you're supposed to have 6 per group.
We also have Margaret with a comment / some question here too. And the other thing is, I don't know if it's also a consideration, Stephen can answer this, but certainly for a volume type group, it's easier to have 6 per group. But when you get into the classification, like the axle factors or the class factor groups, having 6 per group might really be hard for states to meet that requirement. I'm guessing for sure, because class isn't necessarily as commonly collected. I'm going to scroll down and see. No, maybe he's going to leave it at the 6 per group. But anyway, that was just a comment that I know it's easier to have more sites in a group when it's a volume group versus a class group. And then I have Margaret's question. Do many states have to have regional, seasonal factor groups for the same type of road and use? We are looking at potentially creating factor groups based on region because northern Idaho winters are different than southern Idaho winters from eastern Idaho winters. I don't think there's any have to have in that equation, but I'll let someone else.
It sounds like she's
I think
asking.
that's exactly where we
most
work
states
with.
do have regional factor groups. We just saw one on that slide. But yeah, if any states want to chime in. Or provinces. I'm sorry, BC.
I know I tried to start out using clients because we could have also had some of the MPOs join. I'm not sure that we do at the moment, but yes, using the right word, client.
Okay, should we wrap up now?
Nicholas said that they're using northern and southern groups for recreational. So recreational northern, recreational southern. Steven says sometimes the number of sites per group varies when one uses some of the same sites for class factoring. This can thin the herd a little bit.
Yeah.
Okay, so we're at 11:50.